Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this review of week 1. So we covered powers of numbers and square and cube roots this week. So if we have something like this, it is read as 4 to the power of 3. So this number here is called the power or index, and this number the base. The power tells us how many times we multiply the base by itself. So 4 to the power of 3 is 4 times 4 times 4. We times 4 by itself 3 times. So we say this is written in index form because it has the index, and when we write out the sum, it's called expanded form. So 4 to the power of 3 actually equals 64. It's not 12. Some people forget that this doesn't mean 4 times 3. It means 4 times itself 3 times. So when we raise something to the power of 3, we have a special name. It's called cubing. This is also called 4 cubed. So when we raise to the power of 2, it's called squared. So 5 to the power of 2 means 5 squared, or 5 times 5, which is equal to 25. So 25 is an example of a square number or a perfect square because it can be written as a whole number times by itself. So these are the first 20 perfect squares from 1 to 400. All of these are perfect squares because they can be written as a number multiplied by itself. So 196 is a perfect square. It can be written as 14 times 14. So any number not on this list is not a perfect square. So for example, you'll see 20 is not on this list. There is no whole number you can multiply by itself to get 20. That's why 20 is not a perfect square. So I want you to learn these perfect squares because they come in handy, not only when we're doing square roots, but they can also help with other mental calculations. If you know the first 20 perfect squares, it can also allow you to find higher squares. So for example, let's say I wanted to calculate 120 squared. Well, 120 is just 12 times 10. So if I want to calculate 120 squared, it's just 12 squared times 10 squared. So 12 squared is 144, we see from that list. 10 squared is 100. When you multiply things by 100, it's easy. We're just going to add 2 zeros on the end. So it turns out 120 squared is 144 with 2 zeros, 14,400. I was able to do that without a calculator because I knew my perfect squares. So also remember, we're not allowed to use calculators in class, so very important we know these to help us with our mental arithmetic. So if you're given a question like this, where you're asked what number goes in the box to make this a true statement, you're asked how many times can you multiply 2 by itself to get 16. So if you go 2 by 2, you get 4, times by 2, you get 8, 2 cubed is 8, times by 2, you get 16. If you multiply 2 by itself 4 times, you get 16. So that's all we need to know for powers of numbers, although we'll use perfect squares in the next slide. Let's now look at square and cube roots. So it turns out that square root undoes squaring in exactly the same way multiplication and division undo each other. You know, if you multiply a number by 4, then you divide by 4, you're back to where you started. If you take a number like 7 and square it, you get 49, and if you square root, you're back where you started. 7 squared is 49, so the square root of 49, that's what this symbol here means, square root of 49 is 7. If you're asked, say, the square root of 81, you're being asked, which number do you square? Which number do you multiply by itself to get 81? And the answer is 9. So unfortunately, you just have to know the perfect squares that were on the previous slide. So if you know that 18 squared equals 324, that means that the square root of 324 is equal to 18. Knowing your perfect squares is great. So when you square root a perfect square, you get a whole number. 49, 81, and 324 are all perfect squares. But if you square root a non-perfect square, you won't get a whole number. So let's say I wanted to square root 30. 30 is not a perfect square, so this wouldn't be a whole number. So I don't expect you to know what it is off the top of your head. That's hard. It's getting close to 5.5. But What we need to be able to do is tell without a calculator which two whole numbers it lies between. So we need to know perfect squares on either side of 30. So the next lowest perfect square is 25, and the next highest is 36. See, I'm using these symbols here. This mathematically says square root of 30 is between root 25 and root 36. Because this is a whole number, this is a whole number because they're perfect squares. Root 25 is 5, root 36 is 6. So the square root of 30 is between 5 and 6. As I said, it's going to be around 5.5. So you need to be able to take a non-perfect square and tell me between which two integers, which two whole numbers, its square root lies. So cube roots are very similar. They don't undo squaring though, they undo cubing. So if we had something like cube root of 8, that's what this symbol here means, cube root of 8. You're saying which number do you multiply by itself 3 times to get 8? And the answer is, of course, 2. If I said this cube root of 125, you're being asked which number, when you cube it, when you multiply by itself 3 times, gives 125. And the answer would be 5. All right, thanks so much. You're doing a great job. Keep it up. This has been the luckiest maths teacher in the world. Have a great day.